Confusing math. Actually, the title is strange and confusing math. The reason is you get really unexpected result and you have to think why you got such a result. Okay, let's start with the first one, the x equals 1. So 1 minus 2 is negative 1. That's correct, right? And you take a square on both sides, then you get this, right? So you remove 1 from both sides, you get this. And you know how to factor it, right? So x equals 1 and 3. Wait a minute. We said x is 1. How comes we got x 1 and 3? Can you tell? Yeah. It's strange, isn't it? It's confusing. Okay. The key to this problem is here. Okay. Now, if x minus 2 equals negative 1, then that's correct. Okay. But it's not necessary condition for this. So what's happened is this is not a necessary condition for this. Okay, it's a sufficient condition. That means each step somewhere introduced something else. Okay, you remember? This is necessary condition, sufficient condition. Okay, you expanded x value here from here to this area, and that includes 3. X equals 3 is the condition for this, but not the condition for this. Okay, by squaring you did that. So this stage, this is the place you introduced additional value. So after you get the answer, you have to go back and examine. Okay, we assume it's 1, so this is fake answer. Okay. Second problem. Let's solve this equation. Yay, it's easy. We multiply x minus 1, x to both sides, and we multiply x plus 1 on both sides, right? So this is gonna go out, this is gonna go out, we get this, and we eliminate the x here, then 1 equals negative 1. Wow, we proved something very significant here. Did you know 1 equals negative 1? How did this happen? Anybody can tell? Well, this one is the example of starting with wrong equation. You may get any wrong result. Okay. This equation, you look at that. Let's draw the graph x and y, right? And this has singular point at 1. So graph look like that. Okay, how about this guy has a singular point at negative 1, and the graph looks like this and like this. Okay, so you know this guy and this guy never intersect. That means there's no solution. They cannot be equal, but you set it equal. It's like, hey, I'm gonna set this 1 equal -1. That's what you did here. So you get this. If you start with wrong statement, you can come up with any wrong result. You can say 2 equals 0. Yeah, sure. Then I can say 4 equals 2, right? So this is wrong. Anything come out from it is wrong. Got it? I hope you get that. Okay, let's look at the next example. Say S is 1 minus 1 plus 1 minus 1 plus 1 minus 1. Okay? And this series, we put this together, right? Like this. So 0 plus 0 plus 0, so it should be 0. Wait a minute. I'm gonna start from here. Leave 1 here. So this is gonna be 0, 0, 0, 0. So it's all 0 all the time. It should be 1. So depending on how you group together, S can be 0 or 1. What's wrong with that? Well, question here is, who told you you can group terms together? Sure, of course you can, if it's not infinite series. When it's infinite series, since you don't know what's happened here, the rule is different. You cannot group terms together for some cases. What cases? When you know it's not gonna converge into a final number, a finite number, okay? If the series goes infinity or negative infinity or oscillate, you cannot group together, okay? If it's converged to a finite number, then you may. Where does this rule come from? It's actually some mathematicians prove these things, advanced math, and they don't even bother to mention a high school or college, so student doesn't know. So when series doesn't converge, anything can happen. So you cannot do this kind of things, okay? So if you don't know the series is going to converge or not, then better stay away from manipulating terms around, because if you manipulate terms and get the result, I got the result, answer is 1.3, it could be totally wrong. Okay, I hope you enjoyed this videos, and please check out our videos. We have more interesting videos. Thank you for listening.